Okay. Okay, fine. So yeah, so the topic is sentiment analysis of Amazon product reviews. So you must have, since most of you are millennials and you like shopping online rather than shopping offline, and you must have used the various platforms like Flipkart or Amazon or Myntra and so on. And you must have seen people write reviews about different products that they usually buy. And this reviews have lots of different connotations regarding their products. Some people write positive reviews, some people write negative reviews, some people write neutral reviews, not so positive, not so negative. And in this session we will be showing you both theoretically and programmatically using Python how we can solve or how you can predict sentiment of any future reviews. So let's say, why do we need to do sentiment analysis from business perspective? So if you have launched a new product on the digital platform like Amazon or Flipkart, and if people are saying positive about it, then your business is going to increase because people are loving your product. But if somebody, majority of people are speaking negative about it, then you can further improve your product based on the analysis that you have done why people are talking so much negatively about the product. So this is one use case, not only in e-commerce like Flipkart or Amazon. You can also see this sentiment analysis use cases are being developed by other industry as well, especially marketing. When people do campaignings on social media, they use sentiment analysis for on the text on different social media platforms like Twitter or other news forums, blogs and forums. And this has many applications in different industries. So let's see how we can do it. Okay, and I would suggest everyone to go on mute if you are not speaking. Okay, so what does a classifier mean? So the classifier, by the name itself, it means it classifies the text or the sentence into groups basically. And here we'll be only talking about two groups. One is the positive group, another one is the negative group. So if your sentence is highly positive, people are talking positive about your product, then we should be predicting as one here. Plus one means positive review. Or okay, Akshay is telling I'm not able to hear. Is it the same case for everyone? Can everybody hear me?
No, sir, we can hear you.
Okay, so majority of you can hear. So I think you should check your internet connection, or you should check your desktop audio connection, and try reconnecting to the link again. Okay, fine. So moving on. So yeah, so basically classifier means when there will be some input, and once we process that input, once we do some mathematical calculations on that input, the classifier will give me two outputs. And one of the output will be, if the sentence is positive, then I will get it as +1, which means the sentence has positive, the sentiment of that particular sentence is positive. And if it is -1, then the sentiment of that particular sentence will be negative. So this is a over bird eye view kind of a thing of the classifier that we'll be building. Okay, and once we train the data, basically what do we mean by training the data? And what kind of data do we have in sentences? In sentences, what kind of data? So in sentences are made up of different words, and words are the features. Words are the predictor variables, or words are the independent variables in text analytics or in natural language processing applications like this one, sentiment analysis. So when we speak about training the data, we have the independent variable, which are the set of different words, and the dependent variable is either it is positive or it is negative. And so we try to create a function between the independent variable, that is my sentence, and the dependent variable, that is my +1 and -1. And by mapping those x and y, we try to create a function so that if I get a new sentence in future, and if I push that particular sentence into the model, then it can predict what particular class, is it positive or negative, it belongs to. Okay. And when we, ultimately train the data, then it gives us the weights of those particular, words. For example, you can see on the screen, there are so many words like recommend, highly, disappointed, love, it, planet, and bags and wipes. And if you see the value, the fourth column means what, what is the significance of that particular word towards predicting sentiment of these reviews will be. So higher the value, and positive the value, higher positive the value, the more is the significance of that particular word it is towards, predicting positive sentiments. For example, recommend is zero point 0.3, highly is 1.49, so they have positive, as positive positive sentiment when we, predict a sentence, or when we predict a review towards a sentiments, they will contribute to the positive sentiment. But if you see disappointed has got minus 3.957, so it means disappointed is a bad word, or disappointed is related to negative sentiment rather than positive sentiment. So these particular words, so when how we will get these words, for example, this one. So this words, I'm talking about this word, the yellow marked words, these are the weights, these are the weights that we need to, you know uh, find out after the model building. And how we can do it, we'll see.
Sir, from where these values comes?
Pardon, what is the
Sir, from
question?
where sir, from where do these values comes? Like none has given the value of 1.3, recommended as a value of 0.3. So
that
where
was
from these values comes?
that was I have told. If you have listened it carefully, I told these are the values that we'll get once we train the model. So far we have not trained the
Oh,
model, right? We will, when we train the model, these are the coefficients of this particular indexes, these are the coefficients. Let me show you again. This, this point 0.30 or 1.49, these are the weights, or these are the coefficients related to each particular word. For example, 0.30 is a coefficient for the word recommend, 1.49 is a coefficient for the word highly, minus 3.957 is a coefficient for the word disappointed. So these are the coefficients we will learn after training the model. These are my goal, this is my goal, to find out the weights. And I have shown it to you before model building, because I wanted to tell you what is my objective will be when I talk about training the data, right? So these are the weights or values that I will get after training the data, after training the reviews. Did you got it?
yes, sir, got it.
Okay, fine. Moving on, let me show you an example. Suppose, let's say, this is a product. This product is being, selling on Amazon.com. This is a flannel baby wipes product, and this is one of the review that people has one some customer has written on the website. So he has written, it came early and was not disappointed. I love Planet Wise bags, and now my wipe holder. It keeps my Oso Cozy wipes moist and does not leak. Highly recommend it. So, what do you think? Can anyone tell me what do you think this, review will be? Is it positive or negative? What do you think, guys?
Positive.
Yes. So,
Positive.
yes, positive. It seems to be positive,
It's
right?
positive.
When Yes, exactly. It seems to be positive without, building any model. But how, this is our intuition. We humans have, inherent intelligence. We do not need machine learning model, or we do not need AI, because we have been seeing those kind of text throughout our life. And whenever we see one paragraph, our brain inherently tells us that this particular review has to be positive. But machine does not work like this, right? Now I have, pointed out few words in this review, which in, in dark, which in bold letters, this one, these are early, disappointed, love, highly, and recommend. And let's say we have built the model. Let's assume for now we have built the model, and as I told you, once I build the model, I will get the weights and coefficients of all for all the words. And let's say these are a few weights. Let's say disappointed, the coefficient of disappointed is -4. It means disappointed is more related to negative review, negative sentiment rather than positive. And early is related to positive sentiment because its weight is zero point 0.5 in positive direction. Love is 1.5. Similarly, highly is 1.5, and recommend is 0.08. Now if I, because this whole review is consisting of this many words, and Subir is asking, but there is not before disappointed. Yes, yes, there is also not disappointed. So that let's assume not is also there, and the weight or coefficient of not is not much significant. Let's say it is approximately 0 point something, something like that, 0.01, and this is why I have not included here. And whenever you will be doing sentiment analysis or any text analytics or any NLP related application, you will automatically remove these words like it or and or was or not, because these are known as stop words. And stop words does not have any meaningful information for your review, right? Did you get it?
Yeah, question.
Yes.
The question is, disappointment weights is -4, and the early, love, and highly and recommended, there is a different, the weights, right? How
Yes.
do you
Yes.
define, I mean, this 0.5, 1.5, and zero point 0.8 or
Yes.
minus
Yes.
4?
Yes. I have asked you to assume it as of now. These weights I cannot define it. These weights, even the first question that the student before you, he has already asked, where how can we define the weights? I have told him the answer. We cannot define weights. This is just an example. This is just an example to show you how we how we discriminate between positive review and negative review. These are just for assumption. I have taken it. These weights I will get it after I train the model. Did you get it?
All right.
Now just
All
for
right.
just for showing you, just for an example, I have given this as per my choice. But this will be developed, this will be generated once you train the model. This is just an example. Did you get it?
Right,
let's
right.
assume let's assume the coefficients or the weights of these words like this. Let's assume for now. But once these weights or coefficients will be generated once we build the model, but let's assume this for now. Okay. And if I assume these weights, and if I calculate this based on this formula, disappointed minus early plus love and highly recommend, because they are in the positive direction and disappointed is in negative direction. And if you take the arithmetic sum of all these, and you get zero point 0.3, and zero point 0.3 is how much? It is greater than 0. So in classification problems, we tell if the score, this is known as score, this zero point 0.3 here, this zero point 0.3 here is known as sentiment score of of this review. And if the score is greater than 0, then I will classify it as a positive review. And if the score is less than 0, then I will classify it as negative review. For example, let's say this one. So this is another product, and if you see the review goes like this: was so excited to get this product for my baby girl's bedroom, and when I got it back, it is not sticky at all. And every time I walked into the bedroom, I was picking up pieces of the floor. Very, very frustrating. Ended up having so super glue it to the wall. Very disappointing, and I would not waste the time or money on it. Okay. Now, based without thinking about modeling and all, by simply reading this text, what do you think? This review is positive or negative?
Negative. Negative sir, only.
Negative, right? Without even
Yeah.
doing any machine learning or any because as I told you earlier as well, this is our human intelligence, right? So there are so many negative words around it. Frustrating, disappointing, waste. These are all negative. They are all including some negative sentiments in. Although there is a positive word as well. For example, excited. right? Excited generally related to positive sentiment, but there are more negative words like frustrating, disappointing, and waste, which is making the overall review as negative. For example, so frustrating has, let's say, since it is a negative word, it will be have negative coefficient. So let's say the coefficient is minus 3.15. Again, I'm asking you to assume this weights you will get after training the model, okay? But for the sake of understanding right now, just assume the frustrating coefficient is minus 3.15, for disappointing 4.7 minus 4.7, and waste minus 3.6. And as I told you that excited is positive, then I have assumed this the coefficient as 1.5. Now if you do the arithmetic operations to this, and you can see the score is negative 9.95, which is less than 0. So the score that I have got, which is minus 9.95, is less than 0. So that is why I can I will classify this particular review as negative review. Did you got it, everyone, so far?
Yes, sir.
Yes.
So
Okay.
the arithmetic operation that we are performing, is that just a simple summation, or is
Yes,
it that
yes,
negative weights minus positive weights?
yes, it is simple summation. It is simple summation. So I'm doing
Okay, sir.
it is simple summation. Yep. And this is we will learn it when we go further. We'll learn it how I can convert this score into probabilities. Now we have not got into probabilities, now we'll get it there as well. Okay, so this is the simple algorithm how we can do it. So we'll here we will have the sentence from the review, that is my input sentence, and then I will pass into some linear classifier, and once that linear classifier I will pass into linear classifier, then it will give me this table, this word and coefficient. So the two students that have asked me about how I got the weights or how I got the coefficients, so I will get the coefficients once I pass this sentence to the linear classifier, and once the model gets trained, then I will get one coefficient for each and every word. Okay, Madhavi Jetli, she's asking what if we, okay, let me, what if we get sentiment score 0, then what can we say about? That's a very great question, Madhavi. So whenever we get the score as 0 or approximately equal to 0, we are not sure, we're not 100% sure that it is highly positive or it is highly negative. Then we can call it as neutral kind of sentiment. It has, it is neither so much positive nor so much into negative. And that is why we come up with probabilities rather than hard labels that it is +1 or it is -1. Rather than predicting hard labels, we always predict probabilities whenever we do classification problems. So why we do why do we do probability? To this is the answer that the Madhavi has just asked. So if we get the score as 0, so there is a function called sigmoid function, and if you pass 0 to sigmoid, then we get the value as 0.5. So it means that this particular sentence has 50% probability of becoming positive and 50% probability of becoming negative. So that is why we cannot say for sure that this particular sentence is highly positive or this particular sentence is highly negative. It is in between, it is neutral. So I will come back to your question, Madhavi, once again once we move ahead in this session. Okay, so once I pass the sentence, the input into the linear classifier, then once I will get a table where there will be word and there will be its corresponding coefficients. And once I get this coefficients, then I calculate score, which is the simple arithmetic operations just I explained. And if the score is greater than 0, then I will predict it as positive, else it will be negative. Okay. Yajat has asked question. In the first case, we used not disappointed as a negative. No, we did not use not disappointed. Yajat, we only use disappointed. We only use disappointed, not disappointed. Okay, not disappointed is a positive connotation. It is not negative. We only use disappointed as negative. Yes, but it meant not disappointed. So that was just an example, Yajat. So if you go here, so there are so many words here, right? It came, if you know split it by blank spaces, this is called, this is known as tokenization. This is known as if you tokenize this whole paragraph, it will be, there will be so many words. One, let's say 1 2 3 4 5 6 7, there are 7 words in the first line, and there are 4 lines, so let's say there will be 28 words. So I cannot show 28 words in this table, in this slide, right? So that's why I have only shown you some few words, not the complete word. Obviously, if you also, when you will be doing pre-processing of this text, then you'll be removing some of the words, like yes, tf-idf, somebody has said, yes, that's also a feature extraction technique. Yes, you are correct. And when we'll be doing pre-processing, then lots of words, lots of these words, like was, and, not, my, it, these words will get disappeared, these words will disappear, only few of them will be there, right? So so for example, bags will be there, but again, the I have not taken all everything in this slide, so I can only focus on few of the words. But in the final model, there will be all the words will be present. Bags will also be present, wipe will also be present, holder will also be present. But this is just an example. Okay, did you got it, Yazat? Okay, fine. So, mathematically, now let's think how mathematically it will look like. So there is a concept called decision boundary. And let's say we have only 2 words in a review. Let's say there is a review, and this is a highly not realistic review, because in a review there will be multiple words, and with 2 words you cannot create one particular sentence. But let's assume it for now, for sake of understanding. Yes, let's say there is 2 words, awesome and awful. Okay, and this is whole review, awesome and awful. Now you have trained your model. Let's assume you have trained your model, and your model looks like this is your, this yellow line is your decision boundary. And since there are only 2 words, then this will be your 2 independent variable. On x-axis you can see the number of awesome, and on y-axis you can see number of awful. Okay, and the coefficient, this is the 1.0 is the coefficient for awesome, which will get after model training, and this negative 1.5 is the coefficient for awful, and this will get after training, after model training. But for sake of understanding, let's assume these are the coefficients of awesome and awful respectively. Now this score of x is, we can also write it as y, which is my dependent variable. So y is equal to 1 times awesome minus 1.5 times awful. And if you plot this line, this is an equation of line, right, where awesome is in x-axis, awful is in y-axis. And if you plot this line will look like this, and this any point on this line will be equal to 0, and any point on this below this line will be greater than 0, and any point above this line will be less than 0. So what I have told you earlier is, if whenever you get the score, and if it is greater than 0, then I will predict it as positive. And if it is the score is less than 0, I will predict it as negative, right? So this is my machine learning model. So this, what is my model? This line, this equation of line is my model. So this is my model, this, or this is my classifier, right? Now
Sir,
let's say,
and the one
yes,
thing, will this line not have an intercept? It will have an intercept, I think.
it will it
It
will
will
it will
not.
have an intercept as well. It will have an intercept as well. Yes, you are correct, but let's assume the intercept is 0 as of now. Let's assume the
Okay,
intercept
okay.
is 0 as of now. For example, if you see the second slide that I have shown you earlier, let me go there. You can see that this none, you can see this none, this is the intercept, this is the
Yes.
intercept. In the final model you will
Okay, okay.
definitely have intercept. This is just
Okay.
for sake of understanding, for simplicity, I have removed intercept as of now. But certainly you are correct, there will be intercept as well. So many people do not understand visually what the model looks like. So just to show them, so this is my model, this equation of line, this is my model, right? Now if there is any review, Is intercept is error? No, no, no. Intercept is not error. Intercept is not error. Okay, now I have a question for you, and tell me if I have a review where awesome is appearing 3 times and awful is appearing 1 time, what the sentiment will be? Will it be positive or will it be negative? And
Positive,
why?
Positive.
sir.
Positive.
And what is the score? What the score will
Positive.
be? How much will be the score?
1.5.
1.5.
1.5.
1.5. How you got 1.5? Because I have told awesome number of awesome is 3, so a coefficient of awesome is 1, so 1 into 3 is 3, and number of awful is 1, and coefficient of awful is 1.5, and 1.5 time into 1 is 1.5, so overall 3 minus 1.5, which is 1.5. Exactly, you all of you are exactly correct, right? So this the score will be 1.5, and if the score is greater than 0, then I will predict it as positive, right? So I think you have understood this concept. Okay, great. Moving on. Now let's see what happens. What happens if I, retrain the model? Let's say, I retrain the model, and now I am, giving the coefficient. Now I am getting the coefficient of awful as -3 rather than negative 1.5. Earlier I was getting as 1.5, and now I am getting it as -3. Now, if now so this was my earlier classifier, earlier model. Let's say this is m1, this is m1, where the coefficient of awful was negative 1.5 and awesome was 1. And now this is my second classifier. Oh, sorry. This was my first classifier. This was my first classifier M1, where I also have included intercept equal to 1, and this is my second classifier where awful is the coefficient of awful is -3. Now, what do you think? Which particular classifier is better as per you? M1 or M2?
They both are equal.
Majority of you are saying M1, and you guys are absolutely correct. M1 is the better classifier, because this particular point here, say this particular point is a positive sentiment word, and M1 is correctly able to predict this as positive. But if you see M2, this point lies above the M2 line, and if this point lies above the M2 line, this means this particular sentence has negative review, which is incorrect, right? So that is why M1 is predicting every review correctly. If it is negative, then it is able to predict it as negative, and if it is positive, then M1 is able to predict that particular review as positive. But whereas M2 is not able to classify all the negatives, all the positives correctly, so it has misclassified this data point as negative. So that is why M1 is a better classifier than M2. So this way this way you can create so many classifiers. This way you can create so many classifiers, but your ultimate objective will be just to take that particular classifier where the accuracy is maximum, right? Now someone is saying, okay, let me take it. Can you, Gibran is asking, could you repeat the slide once more? Subir, could you repeat the slide once more? Okay, so I'm repeating this slide once more. What I'm saying is, so this was my first model. Okay, this was my first model where, and I have also included this intercept 1.0. Earlier the intercept was 0. Now I have also included one intercept term 1.0. And awesome, the coefficient of awesome is 1.0, and coefficient of awful is 1.5, and it has correctly predicted this above point as negative and below points as positive. Okay, now what I have done is I have retrained the model. Retraining means what? Retraining means I am changing the coefficients of the words, and I am changing the awful. Earlier the coefficient of awful was -1, but now I have increased the coefficient to -3 by retraining the model. Now the new equation of line, the new classifier looks like this. this is my second classifier. This was my classifier 1 or model 1, and this is my model 2. Okay, and what I'm saying is, out of these two classifiers, which particular classifier is able to predict the sentences correctly? It is M1, because all the negatives are negatives for M1 and all the positives are positives for M1. But for M2, this particular observation, earlier it was positive. Actually, in actual it is positive, but this particular classifier M2, it is predicting it as negative review, which is incorrect, right? So there is a misclassification done by the classifier M2, and for M1 it is 100% correct. So that the motive of explaining this slide is, you can create so many classifiers, like this one as well, like this one as well, like this one as well. You can create so many classifier, but this classifier is optimal. This classifier is optimal, so you have to choose the optimal classifier. And how I can choose the optimal classifier? Based on the metric called accuracy. So here if you see, the M1 was 100% accurate, but for M2 it has incorrectly classified this data point as negative, whether it should have been positive. So the accuracy for M2 is lesser than 100. So based on the accuracy metric, we'll be choosing the classifier M1 as the optimal classifier. Okay, fine, moving
Hello,
on.
sir.
Yes,
Hello.
yes.
Sir, I had actually a doubt. The point NR, which you marked here in the graph, right? Where
Mhm.
awesome is equal to 4 and awful is equal to 2, right?
Awesome is equal to 4, where awesome is equal to 4. Okay, these are the scales. You're talking about the
Yeah,
x-axis.
these are, yes, the x-axis and the y-axis, right? Here, x-axis is equal to 4 and y-axis is equal to, say, above 2, right?
Okay, okay. Mm-hmm.
Okay, so if you put those value in the score x equation, you see that the score is coming out to be negative.
In which equation? In this equation, right?
In this equation, yeah, yeah.
Yes, yes, yes,
It's coming
yes.
out to be cos
Yes.
of -1. So I
Coming
think M2
exactly.
should be a better estimate, right?
No, 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 no. So see, I have to put it down here. So see, these three data points, they are actually negative. Actually, see, we are doing two things. We are comparing our predicted results with the actual results, right? Let me go back to the previous slide. Let me go back to the previous slide. See, you can see these data points. These are negative. These are the actual values. Okay, these are the actual values. These are the actual values. These are these are the actual, or these are the historical values. Okay, and this is again, this is positive. This is actually, it is positive. So you can see this here. Awesome is 4, right? May I know your name? The person that you have just asked me the question. What is your name?
Yes, sir. It's Mohit. Mohit, sir.
Mohit, yes, yes, Mohit. So you're talking about this point, right? So here,
Yes, sir.
the awesome is 4 and awful is 2, right? 4 comma 2, right? So actually it is positive. And based on this model also, based on this model as well, this particular point is predicted as positive. So there are two things. What is its actual level and what is its predicted level by the classifier? Did you get it, Mohit?
Yes, sir. I
No?
got your point. I got your point. These are the
Yeah.
actual values. Okay.
These are the actual values. Now if you go to the second classifier, now you go to the second classifier, just a minute. Now if you go to the second classifier, here this point 4 comma 2, actually it was positive, right? This point actually it was positive, but based on this particular classifier it is coming out to be negative, whether it should not have been, right, Mohit? And that is why this point is
Yes,
being
sir.
misclassified by this classifier M2. Did you get it?
I got it. I got it, sir. Thank you.
Okay, great, fine. Okay, moving ahead. So yeah, so right now, just for the sake of understanding, I have only taken two variables, which is awesome and awful. But when you'll be doing actual real life problem, then you'll be getting so many variables, so many. You'll be getting into tens of thousands, 10,000 words, 50,000 words, maybe 1 lakh words. And if you see, there are two words and the decision boundary was a straight line, right? And had there been three words, then decision boundary would have been plane, right? Because my in independent variable space would be three-dimensional, and a plane can dissect a three-dimensional into two parts, right? One part will be above the plane and another part will be below the plane. But now in real life, as I said, the number of features will be more than 1,000 or 10,000, 50,000, 1 lakh. This is very difficult to visualize. And those boundaries, where we have so many coefficients, so many independent variables, those kind of boundaries are known as hyperplane, right? So they are more complicated shapes, so we cannot visualize this. So that's why for understanding, I have used only two variables, awful and awesome. But in real life, this is not the case. Okay, so yeah, so now so far I have been I have been using the score value, and if the score is greater than 0, it will be +1. If the score is less than 0, it will be -1, that is negative review. But how sure about the prediction, right? So generally, whenever we do classification problems, we do not predict the labels, we predict the probability. With how much probability? For example, let's say there is an example, the product and the product and everything else were awesome, right? So this seems to be a positive, this is a definite positive review. But if I tell you this review, the product was good, the delivery was okay, do you think it is definitely positive? What do you think?
Not sure.
We're not sure, right? He is okay kind, he has some okay kind of an approach or opinion about that product. He liked the product, but delivery could have been much better, right? So even though it seems like little bit positive, but not. Guys, can you please mute? Okay, fine. So whoever not speaking, can you please go on mute? Okay. So yeah, so if you compare these two products, these two reviews, the left hand side is have some higher probability of being predicted as positive sentiment, and this the second, the product was good, the delivery was okay, he is not seem to be very much confident about his positive sentiment. So their probability will be very less, not 100% probability, right? So that is what I have I have written at the below, that this will be +1 with high probability, and this particular review will also be positive one, but the probability will be little bit towards 50% or 60% or 70%, but not 90%, right? So that is why instead of going to +1 or -1, if we can also give the probability, associate probability with it, then also it will solve our purpose, right? So but how can we do it? How can we convert the score numbers into probability? Let's check that out. Okay, so as I said, this is my scale now. This is my scale from 0 to 1, since probability can only have values from 0 to 1. And if the probability, so this is my probability of being positive. So if for each sentences or if for each reviews my probability of getting positive is 0, that means that particular review is negative. Since if it is the probability of being positive is 0, it means it is negative. And if the probability of being positive is 1, then it means the reviews are absolutely positive. And if the probability is near about 50%, then we are not particularly sure if the reviews are positive or negative. They might be positive, they might be negative. As the girl, I forgot her name, she asked what if we get score as 0. So these are the position where we get the score as 0, right? So these are the position where we get score as 0. Okay, yeah, so the similar
You
again,
mean you mean hello?
yes, go on.
You mean to say if anything comes in between 0.5,
Mm-hmm.
it is 0?
No, it will, I'm saying the score. Do you remember the score value? Score, where I
Yeah.
did the arithmetic operation. So if I get so many sentences with so I will never get zero. Okay, I will get absolute approximately zero. For example, 0.01 or 0.02. Then if I calculate the probability of those sentences being positive, it will be around 50%. It might be 50%, might be 51%, or might be 49%. So approximately it will be equal to zero, and the probability will be approximately equal to 50%. Did you get it? Did you get it?
Right.
I can't hear you. Okay, fine. Somebody asked some question. Okay. What if the probability lies between 0 to 0.5? Yes, yes, you are absolutely correct. So Anushka, you are absolutely correct. If the probability of that particular review is lying between 0.0 to 0.5, then I will predict that particular review to be negative. If that particular review's probability is lying between 0.5 to 1, then I will be predicting that particular review to be positive. Okay. And if some sentences have the reviews exactly equal to 0.5, then I can classify it as neutral review. Okay, now let's not go into details, as we are very short of time, only 15 minutes left. Yes, I will just show you how I can convert those score into the probabilities, right? I have only been telling about I need to convert that score into probability. So how I can do that? So let's say this is the arithmetic operation that we have seen earlier as well in the examples that I have shown you. This w0 is the weight of the first word. For example, let's say this word is disappointing, and let's say this h1 is the second word. Let's say this is exciting, and so on. So there will be so many words in my sentence, right? And this w1 w0 w1 wd, I will get this from where I will get this once I train my model. So once I train my model, I will get weights or coefficients for every word, and once I get these numbers, when I do the arithmetic operation, simple summation, then I will get the score. Now what is the domain of this score? The domain, or what values can the score take, right? This score can take values from negative infinity to plus infinity. Now my task is to convert this negative infinity to plus infinity to the scale of 0 to 1, because I want to convert the scale into the score into probability, right? And probability lies between 0 to 1. Now how I can convert this negative infinity to plus infinity number to 0 to 1? So to solve this problem, there is a function called sigmoid function, and sigmoid function looks like this. If this is my y-axis, this is my x-axis, this is y equal to 1, and this is y equal to 0.5. So sigmoid function looks like this. Okay, and let's say this is minus infinity and this is plus infinity. So any number, if you are suppose let's say score you have got, yes, Tejas is saying logistic, yes, you are correct. So in logistic regression as well, so this is a logistic regression where trying to find out the positive and negative review based on logistic regression only. Yes, so if I get the score as negative, minus infinity, a very high number, then the logistic, the sigmoid value will give me the value as it will be approximately near to zero, right? This is zero value, right? This is approximately zero. And if I get a very high positive number which is moving towards infinity plus infinity, then I will get y is approximately equal to 1. And if I get the score as 0, I again forgot the girl's name, I think she was Madhavi asked, what if I get score as 0? If I get score as 0, so 0 is this. If I get this point, then y will be 0.5. So that's it. So if I'm getting towards negative infinity, then my probability will be 0. If I'm getting score as positive infinity, then I will get 1. And if I get score as 0, then probability will be 0.5. And this function is known as This function is known as sigmoid function. Okay, this function is known as sigmoid function. So yeah, so this way we are converting scores into probabilities. Okay, so yeah, so this is another way of showing that sigmoid function. Okay, now let us now quickly go through the coding part. We are only 10 minutes left. So here I have already done the coding for you, and I'm not executing it because it will take lots and lots of time. And here I have used a different library called GraphLab Create. And if you see, so this is a company called Turi, and Turi, they have this package called GraphLab, import GraphLab. So from GraphLab you'll be you'll be able to use this sentiment analysis by default. They have pre-built models which you can use. So firstly I have imported the libraries, then I have created this data frame where I have passing the GraphLab version of this product, Amazon baby products. And then these are the product, this is my data set basically. So this is the first variable called name, what is the name of the product, and what is its review, and what is its rating. Now this particular data set I'll not be using name for my features. I'll be using reviews because I need to predict GraphLab is free. I think GraphLab is not free completely, but if you are a student, then you'll be getting 6 months of its license for free, I guess. You just need to check on its website. Okay, so if you so the main independent variable here will be the reviews. And what will be the dependent variable? Guys, anyone can tell me what will be the dependent variable here in this data frame? Because in a supervised machine learning we need the independent variable and dependent variable. Rating. So Ishan, you are not exactly correct. So rating, we're not predicting rating, we're predicting sentiment.
So +1 and -1.
+1 and -1, exactly. +1 and -1 will be my target label, but in this data frame I cannot see +1 and -1. So how I can create this +1 and -1? Anyone?
Using reviews tokenization.
No, not using reviews,
So
using rating. Using ratings, yes. So what I can do is what I will do is, so this is the one. So first I am removing -3. For first I am removing rating equal to 3, because rating equal to 3 is it's a neutral rating, right? And I do not want to predict neutral ratings, I want to predict positive or negative. So what I will do is, from here, for I will create a new column called sentiment, and I will do what if that particular review is 4 greater than 3, which is 4 and 5, then I will put it as +1. And if that particular rating for particular review will be 1 or 2, then I will put it as -1. So I will be creating that target label statement based on this variable called rating. Okay, if it is more than 3, then it will be 1, and if it is less than 3, then it will be -1.
You mean to
Now,
say you are scaling down?
not scaling down, I'm creating a new variable altogether from the variable called rating. Scaling down is a different concept altogether. I'm not scaling down, I'm just creating a new variable based on rating. And if rating is 4 and 5, then it means this particular review is highly positive. And if the rating is 1 or 2, then this particular review is highly negative. Okay,
Okay.
and that particular new variable, which is sentiment, will be used as target variable or dependent variable in my machine learning model. Now my next thing is to find out the features from this particular reviews. So if you see, this is a paragraph, right? This one is a paragraph, this one is a paragraph, and this one is a paragraph, and all of them are not of similar length, right? But if you have basic, very basic knowledge of machine learning, and there we need to have a structured data set or structured feature matrix. But if we have so many different lengths of reviews, then I cannot directly pass it into the model. So I need to convert this paragraphs into some structured format, and there are so many ways of doing this. One such way, one of the students this ping, when I was explaining this concept, he told me about TF-IDF. Yes, so TF-IDF stands for term frequency inverse document frequency. I do not have much time to explain it to you now because of lack of time, but this is one of the way where we can extract features from text. And the other one is count vectorizer. So I can count how many, for example, this is a word, for example, flannel, right? Flannel is a word. So how many times this particular word is appearing in this paragraph? Or for example, opinion, or how many times this particular word is appearing in this paragraph, right? So this is known as word vectors. Sorry, this is known as count vector. So count vector is another way of extracting features from text data. TF-IDF is second option to to generate features from text paragraphs. And the third is, which is very new and which is very popular as well nowadays, that is known as word vectors. And this is an AI based, deep learning based model, word vectors. There are two word vectors currently. One of them is known as Glove. Another one is Google word vectors. Let me show you Glove vectors. So this was prepared by Stanford University professors, global vectors for word representation. You can use that as well. Or otherwise, Google has also created one word vector, Google word vector. You can also use word2vec, Google word2vec. So these are very famous nowadays. So you can also use word2vec for feature extraction, but here I have used count vector. So let's see one of the examples. Let's say I am extracting 269th observation from the dataset products. And what are the observations? The name of the product is this, and the rating is 5. That means it is a positive review. And what is the review? A favorite in our house. So this clearly seems to be positive because of the presence of this word called favorite, right? Now whenever we deal with text data, we cannot use it in our machine learning model without doing pre-processing. For example, if you see house, the house is followed by an exclamation mark. So these are few unnecessary tokens that are present in the text, and we need to remove those before passing into the machine learning model. So here I'm doing two pre-processing steps. One is, first I'm removing all the punctuations from the reviews, and then I'm transforming that reviews into word counts. Word count, what do we mean by word count? As I have already told, how many times, for example, favorite is appearing in this review, how many times house is appearing in this review. So this is known as word count. So this is the code for this word count. And once you word count and removing punctuation, and once you do that, this is the output. So for the same product, if you see word count, now A is appearing one time, favorite is appearing one time, house is appearing one time, in is appearing one time, hour is appearing one time. And this way I can get this word vector for all the reviews present in the data set. And this is the word count. This is the word count for all the reviews, right? So this word count will now be my feature vector or the independent vector, and this sentiment will be my dependent vector, or the y vector, or the labels, right? So I can simply ignore these three variables: name, review, and rating. Now this will be my input x into the model, and this is my class label from which it will map both this independent and dependent, and it will learn the weights. So if you remember, a few of the students have asked me how I am getting the weights for disappointment, for other words. So when I'll be passing this word count and this sentiment one, it will map each other. It will learn the weights for and, it will learn the weight for love, it will learn the weight for highly, it will learn the weight for quit, it will learn the weights or coefficients for comfortable, it will learn the weights for ingenious, and so on. So for every word it will learn the weights. Okay. And where this training is going on, this training is going on in this line, graphlab dot logistic regression, then dot create, and obviously we need to do data split as well. Training and testing, we cannot do training on the complete data because we'll not be able to make sure how our model has created, how our model has developed. So we'll be dividing this complete data set into 80-20%, where 80% will be in training data and 20% will be in test data. So once we build the model, sentiment model, we can check its accuracy on testing data. If both the accuracy, training and testing, are almost equal, that means that our model has trained well. So this is just one line of code you need to do, you need to pass in. So here the feature variable is word count, as I have told, and the target variable is sentiment, and based on this it will train. And after training, After training, this is my model. This is my sentiment model. So it is showing what class it belongs to. This is a logistic classifier. How many number of coefficients are there? So this means, what does this mean? So 1,21,713 number of coefficients. What does this mean? This means that in my word vectors, there were these many number of words, these many number of words present in the data set. So, and for every word, they have their corresponding coefficients, right? Number of examples, what does this mean? Number of example means number of observations in the data set. Okay. Number of classes, what does this mean? Number of classes means +1 and -1, positive and negative, right? And so on. So this is my model summary. Yep, so that's it. This is a very brief overview of sentiment analysis. This is just a motivation for you guys, and you need to keep learning from different sources, or you can also enroll for this course where you'll be learning in detail about sentiment analysis or any other machine learning techniques that can be used in text data. Okay, so yeah, so that is it from my side. And if you have further questions, then you can contact the IV team, and then you can let them know what your questions are, and they will get back to you with the answers. I hope you have learned something out of it, because it seems all of you are very beginners. You do not know much about machine learning with text data, and this is just a primer on how to handle text data and how it works, how machine learning works with how logistic regression works with text data. Okay, great. Have a great weekend. Stay safe. Do not move out of your home. Stay at home. Okay, and if you have any questions, just let the IB team know and they will get back to you. Okay, fine. See you. Bye.
Bye, sir.
Bye
Yep.
bye.
Bye, sir.
Bye.
Bye, sir.
Excuse me, sir.